this unit is pretty beefy, and by the end we're going to have so much stuff that we have written down about circles and circle relationships. So we'll do a quiz partway through, and I don't think we'll probably do that this week, but probably next week we'll be getting somewhere near one. So I think it's good periodically to just do a brief review of what we've talked about. So far, equation of a circle. Actually, even before that, radius, diameter. Remember radius, like physically you can do it with your arms, like radius is center to edge, diameter is like 2 arms, right, all the way across through the center. Okay, circumference is pi times diameter, or 2 radiuses times pi. We typically use this one that I boxed, that's why it's boxed. And then pi r squared for area. And it seemed like that was getting picked up pretty good last week. And then equation of a circle, we did write lots of equations of circles. So remember HK is the center, and then the radius is just using the distance formula to say how far apart the circle edge and center are. That's all. So the radius, if we square root that, it's the distance, the specific distance, otherwise it's just r squared. Okay, from there we got into some, well actually equation was new. Before that it was probably review. And then central angle was new. Remember that's formed on the center. And it's just the angle between the 2 radiuses that you're measuring with. And that intercepts an arc. So if you think of it as cutting off a piece of the edge of the circle, that's the arc. And we use that to find things like arc measure, arc length, and that angle we used also for area of the sector. So let's kind of review these. Remember, minor arc typically is 2 letters. It's not always. Sometimes, because if we have letters everywhere in our figure, sometimes we do use more than 1, or more than 2. But typically it's 2, and it's smaller than the half circle. Whereas the major arc is bigger than the half circle, like this one would be the pink one. And usually has 3 letters. Okay, remember this next section here can get confused. So just make sure you're reviewing and keeping them straight. Remember, arc measure was the angle measure that the angle passes through to make the arc. So if you think about starting here and passing through an angle to make, let's do it this way, passing through that angle to make that pink arc right there, the angle that it sweeps through is the arc measure. Whereas the length, if you took a tape measure and measured around it, that would be the arc length. Okay? So think about opening a door. Like someone maybe knocks on your bedroom door and you open it. Well, how far it sweeps through at the hinge, right? Like my elbow being the hinge. The angle that it passes through is the measure. Whereas if you took a string on the end of your door and strung it across where it passes on the end of the door, that's the arc length. Does that kind of help review? Okay. So one was in degrees and one was in inches, feet, centimeters, that kind of thing. Okay, and then quick review. Theta out of 360 is the fraction of the circle that the arc is taking. And then we just multiply by the circumference. So if the whole circle was 10 feet, then whatever fraction of 10 feet the angle was, that's how we find this arc length. And then same thing with the area. Same fraction, only this time we're just saying of the area. So fraction of the area formula. Does that all seem a little bit familiar from last week? Okay. Segment was where we left off, and it was quite an undertaking. So I think we'll review it here in just a few minutes. Before we do that, here's an example picture of a segment. So it's just this little yellow part. So I'm going to use this picture to review lots of things, okay? And you're welcome to write it somewhere if you want, or you can just follow along and just work with me on it, but let's say I put something like this on here, like an XY axis, and I tell you that this center is like maybe 6 and 5. So what would the equation of that line, of that circle be? The equation of the circle. Alright, so remember to start with your, what I call like a generic or a blank formula. Just because it tells you where to plug stuff then. Okay, so dropping down, we know x. What is h? 6. So x minus 6 squared plus y minus 5. So hk is the center. Equals, not 8. Yeah, 8 squared, right? So 64. Okay, so that equation is for that circle where it is currently with a radius of 8. Alright, from there I could say, what is the measure of arc? Let's do it this way. P there. What is the measure of arc XPY? Measure of arc XPY. Okay, so first of all, this is the major arc, so we're going this way around all the way to Y. And so we know the whole thing is what? 360. And here's 60 of it. So we know this is also 60 degrees. So that leaves 300 for our major arc. Okay, everybody good on that? That was a major arc. How about the length? So I don't need the M. The length of arc XY. How would we figure that out? Yeah. Okay. Well, as soon as you see arc length, what should you write down first? So write your formula for arc length. Another good thing about doing this is that it keeps you from mixing it up with measure if you write your formula right away. So as soon as you see length, write that down. And then I'm just adding this like that. Okay, so what do we know in here? We do know theta, which is what? And what else? Well, we sort of do. We don't actually know the diameter. We know the radius. What's the diameter? 16, yeah. And just, how did you get that?
18 times.
Good. anyway, we just plug this in. This is 1/6. So this is 1/6 times 16 pi. I think I can just stick a pi there and it's good. Yeah, so 8.4. Cool. Next, let's do the area of that sector. So we're talking about R, Y, and X, that sector. We didn't really talk about it a way to name a sector. So I'll just kind of draw it in here. Isn't it? R, Y, and X. Okay, so look in your notes. How do we find area of a sector? Yep, write down the formula. So, area of the sector. Yeah. So remember this pi times radius squared is the area of the whole circle, and then this theta over 360 tells us what fraction of the whole circle we're taking, which is just all dependent on that central angle. Okay, so we'll plug in what we know, which is still just 60 out of 360, and now just 8 squared. So this is 1/6 times 64 pi, which is like, it's 10 2/3 times pi. So I'll just type it in. 1/6 times 64 pi gives us 33.5. Alright, so just kind of plugging stuff in formulas a lot, right? That's kind of what we've done. How'd this go? I know I didn't have you do it, but you feel like you're tracking with it pretty well? Alright, and then finally, the green highlighted portion called the segment. And for that, let's turn to the notes that we wrote on Friday. The example, I mean. And recall that it was a lot. There was a certain part of this that was the most work. And the other two parts weren't too bad. Altogether, though, it's kind of a lot of work. So first of all, the segment is that little piece trapped between the triangle and the edge of the circle. So up here it's yellow. And to find that, again, I'm not going to leave this on here, but we take this whole sector, we find that area, which we had the formula for, we just used it, and then we just subtract off the area of the triangle, and that leaves the yellow. So does everybody remember that concept? Whole sector minus triangle. So that's what we wrote right here. The big problem was the triangle is kind of a pain to find the area of. That was really where most of the work came from.
Cried that day.
Who did?
I did.
You did? So, I'll zoom in a little bit. So just kind of look at your notes or look up here, either way. So we just did an example of the sector. It's the same thing. Theta out of 360, in this case theta was 144. And then r squared, pi r squared, in this case r was 5. So we just plugged that in and got 31.4. No big deal there? Okay. That was area of the sector. Now we needed area of the triangle. But the problem is, for area of a triangle, we need base and height, and we didn't have that. So we have to kind of use trig to get around the fact that we only have a radius and a central angle. So here's what we did. Zoom in on the triangle and note that the base of our triangle in this case is the chord, and I didn't put letters, but it would be this line here. And the height we have nothing for. So draw it in, and then zoom in even further on just half of that triangle. And I think you can do this every time. Not I think you can, I think you should, is what I meant to say. So we've zoomed in on half of the little triangle. So now the angle is half, because this is an isosceles triangle. The radius goes on the hypotenuse, and the height is now on the bottom of our triangle, the way I've drawn it. And the x, the big idea there is that it's only half of the base, because I only took half of the whole triangle. So don't miss that little step. Okay, so here's how we work through that. Using the central, or half of the central angle, h is going to be the cosine, so adjacent over hypotenuse, and then we just solved. X is going to be the sine, opposite over hypotenuse, and we solved for x, but then had to double it because it's only half of the base. Double. Okay, once we did all that work, we plugged it back into our area of a triangle formula, which is 1/2 base times height, and we got 7.4. It should be smaller than this one, right? Because it's only part of it. It should be smaller than the sector. If something goes wrong and your triangle is bigger than your sector, then something needs to be fixed. Anyway, after all that work, we just plug it into this kind of simple little formula and subtract the triangle off of the sector, and then you're done.
Kind of simple little formula.
Well, it's just a subtraction formula. That one, the red one, is just subtract. It just has a lot of words in it, but it's the process that you're doing is just subtracting something, right?
So like this same little line. Step 3.
Step 3, yeah. All right, so here's what I want to do. Why don't you draw?
A circle.
I have a star right there. Draw this circle. You could put it in your notes or on a separate sheet of paper. I'm not going to like write through all the notes. We're just going to work through it together.
I wonder if that's completely done without space.
So whole sector, that whole thing, that one's not too bad to find, minus triangle, that one's a pain, then we just subtract. So let's start, we'll kind of format it like our notes. So let's start with area of the sector. So you guys tell me what to write, what to plug in. You can just take turns. Linda, what should I write first? Huh? What? Oh, well, I was just writing the formula, but you're right. Okay, so now let's fill it out. Go ahead. Yeah, you got it. Good. Okay, so 10 squared is 100 times pi is 31.4.
So
No, it isn't. It's 314 times this, times a fourth. So 90, let's clear this out. 90 out of 360 is a fourth, times 100 is our 10 squared, and then you can just stick pi on there. So 78.5. All right. Silvana, what's the next step? Okay. Okay, so first, let's draw the triangle. And guys, I'm drawing it like I see it in the picture. Does that make sense? You don't have to do that, I just like to. Like if the triangle had been here, I would have drawn my triangle like this. Okay? Just because it translates where I'm working better to me. Alright? So we're zoomed in, we know that here's our height. This angle is 90 degrees. And that's probably all. I guess we could write base here if we want, the whole thing. And then we're going to zoom in. You can zoom in on the top or the bottom. Do you guys have a preference? Okay. They're the same, so. So what goes here now? Savannah, how about it's still your turn? In that angle, I mean. Well, we know what it is, because we just wrote the whole thing as. Get rid of this. 10, did you say? Okay, so we're talking about this angle right here. So it was 90, right? So then we split it in half.
Yeah.
So what is it now? Close. Punch it in. There you go. Okay. And then where can I put H in the zoomed in picture? Good. And then what else do we know in here? I can if I want that angle, but I don't need it. But you can if you'd rather. I'm not going to use it. I know this length, right? Is what? Yep. And then this length is my half my base, right? 1/2 the base, which is just this right here. Good? Everybody good on that? Okay, let's solve for these. So x and h, I don't care which one we do first. You start us off. Yes. I mean, you can do law of sines too, if you like it better. If you're going to do law of sines, you'll need that top angle. This part is the same, guys, as your notes. So, what did we do for h? Cosine, right? Because look, here's 45. That is next to it. Remember, adjacent. So it's going to be cosine of 45 equals h over 10. Okay? Let's set up the other one too. What's the x one? Now, it's good for you to be able to figure it out since you can't write examples in your notes, but you can try to remember. It's cosine and sine, right? So x is opposite of 45. So sine of 45 is opposite, which is x, over 10, which is hypotenuse. Good? Okay. So let's go ahead and solve these. How do we get h by itself? What was it?
No, it's time.
Yeah, because it's already divided. So times 10 on both sides. So we'll get 10 cosine 45 for h. And same thing over here. 10 sine 45 for x. And then we just plug those in. Sine and cosine for 45 is the same. Actually, 10 cosine 45. So it's 5 root 2. So 707. Are you guys good with 7.1? And then just to show you, if we did 10 sine 45, same exact thing. And it's in a 45-degree angle. Let's see if I draw that a little better. I'm not drawing it super good, but do you see how these two are congruent? So they're the same length is really what that just told us. Anyway, so x is 707, or 7.1 I guess we said. Alright, but remember x is only half the base. So what do we need to do with that? Yeah. So the base equals 14. Let's do 15.4. Okay. We are still not done with this step because what else do we have to do? It's your turn. We're close though. I just thought of something that might make this easier. Only a little. Huh? Did you lose it?
Yeah.
Okay, we'll swing around to Linda and help him out. Well, we're still trying to find the area of the triangle. So we have one more thing to do, which is to find the area of the triangle. All we know at this point is all the lengths, which is good. Did you find it, Linda? Okay. Trying to help her? Good. Yeah. Now, here's, everybody put your pencils down and listen. This is kind of something you could do to shortcut. Ready? You see how this first thing says half of the base? And this is half of the base? So we actually don't need to write the whole base, do we? Because we're going to, if we do write the whole base, we're going to plug that in here and then take half of it. Which we already knew, because that's all we found. So you could just do x times h, and it's the same thing. If you want to sort of shortcut this a little bit. So x times h would be 7.1 times 7.1 in this case. Oh, I wrote 7.7. That is supposed to be 7.1.
Would you recommend we still have bases?
Go fix that.
Student Maynor Kalada Hara, please come to the main office. Maynor.
All right, so what we were just saying before the break, once you find x, you can actually just plug that in for half the base and do half the base times height. So it's x times b. We can go add that to your notes in a second if you want. And then Dahlia asked, well, should we know, though, that the whole base is 15.2? I would still recommend that you know that you should do that, or that, let me say it this way, know how to do that, because in some of our problems, we're solving for the length of the chord, in this case, NM. So it's not like just ignore the whole base, because it will come up as a separate question. Anyway, so 7.1 squared, this one, times 7.1, and we get 50.4. for that area. Okay, what are we supposed to check between the triangle and the sector before we continue? Here, I'll raise it up, sorry. What should be true about one versus the other at this point? Remember, the triangle has to be smaller. So think about what we're actually finding the area of, which is this part. If the triangle was somehow bigger than the whole purple thing, that would be an issue we'd have to fix. Okay, so right now, in fact, I think I'll just leave this like this. So the triangle, area of the triangle is 50.4. And then area of the whole thing, area of the sector is 78.5. So how do we get this little piece? The ice cream? Or maybe it's a snow cone. This would be the shaved ice. How do we get that part? Yeah, we just subtract. I should have drawn that picture over there. Maybe I'll do that. Do you mind waiting for a second? Okay, so we're trying to find this guy, and so this is step 3, area of the segment is area of the sector minus area of the triangle. So 78.5 minus 50.4, which is basically 20. All right. How'd that feel the second time through? We did the one on Friday, now this one. Does it seem like a little smoother? Okay. Do you want to add the note about the just x times h into your notes? Or would you rather not complicate it, if that's complicating it for you? Find it?
He's like wandering around. I don't know where he is. I went to a class, I thought he'd be in. I just asked another teacher to figure out where he is.
So yes or no on the note? Do you want to add the little x times h thing in there? Okay. I have room. I don't know about you guys. I guess technically it goes into the next section. I'm going to stick it right here. All right. So number 1, 36 pi, and then u squared just means units squared. Like if it was centimeters, that would be centimeters squared. So for the area 36 pi, just multiply 36 by 3 and you'll get like 112 or something. 113, right? Okay. And then arc length was 6 pi, so that one's about 20.
Well,
18.8. Okay, number 2. We just checked yours was a 461. 461 for the area. And then this one was that. 40 what? 3.89. Okay. And then last one. This one's kind of weird. What we call this is exact because we're leaving pi. We're not multiplying by pi, so we call that the exact value. But this says 8 pi over 3 or 8/3 pi. So that's like 2.5 times 3, so like 10, roughly. Okay. And then length 4/3 pi, so that's 1 1/3, so like 4.5. Okay. So it sounds like those went pretty well. Did they? All right. How about the segments? Any questions on those? For these 3? Doing okay with those?
I'm sad.
Okay. Henri in the middle back there. Realized that we just did this one on the board. It's the exact same problem as the one we were doing like during the break. You know, over the one that spanned the break. So if you wrote it down, it's done. It's done. So focus your attention on number 4 and 6 mostly. Now,